Hi, in the last lesson, we talked about how the SN1 mechanism works. So now, in this lesson, we are going to complete the story and talk about SN2 reaction. Right, so SN2, like we mentioned in the first video, it is a second order reaction. Alright, so what it means is that both the Rx and the nucleophile, in this case NH3, they enter and leave in a same step. Alright, we call that a concerted reaction. Alright, so in the same step, one is going to enter and one is going to exit. Alright, and what is going to happen, okay, is that there will be an inversion of configuration. Alright, so I'm going to explain how that works with this diagram here. Okay, so this molecule is going to undergo my SN2 reaction. Alright, so I have to take note that this NH3 is my nucleophile. This second group here is my electrophile, so it must have a delta positive carbon. Alright, so how do I get this delta positive? Is because my chlorine here is delta minus. It's more electronegative. So you must always have this delta plus for it to be an electrophile. And in our SN1 mechanism, we have this positive carbocation. That is our electrophile. Okay, so what I'm going to do here is I'm going to push the arrows, enter together, and break at the same time. Alright, so this is the second order reaction. Okay, both of them occur at the same time. So what is going to happen is, imagine this NH3 is the one that pushes these three groups. So this hydrogen will now be pushed towards here, this hydrogen will now be pushed towards backwards, and this R will be pushed towards the back. Okay, so just imagine when you hold an umbrella and the wind is very strong, it will flip your umbrella over. Alright, so just remember that image. It looks just like SN2. Okay, so pretty much like, let's say I have an umbrella here. Alright, when it flips over, okay, then it looks something like that. Yeah, when the wind starts blowing. Okay, so this is our SN2 mechanism. Okay, so what is going to happen is that the final product, okay, it's always a good way to represent it this way. Okay, looks like this. Right, so all I did was just to shift those hydrogen atoms and the R group towards the back. So I just flip them over. Okay, and what you need to take note of is the charge on the nitrogen atom, because it was neutral, it gave electrons, and then it kicked out the Cl minus. So you also have Cl minus at the other end. So if we take a look at the charges, it is balanced. Okay, because the initial reactants, they are not charged, they are neutral. So the final product should have a conservation of charges. Okay, so in the last step, what is going to happen, okay, is, well, this Cl minus is going to take away one of these protons, right, so that we can liberate the product. Okay, so we get this product here. Okay, and of course, this reactant is able to continue with this reaction, alright, as long as it sees an Rx. Okay, another Rx, and it can continue all the way till you get your quaternary ammonium, alkyl ammonium salt, right, which is your NR4 plus. Okay, but there's a way to slow this down, alright, and it is to add in additional ammonia, alright, excess ammonia. So if you want to stop this thing, you use excess ammonia. Alright, so this is the SN2 mechanism. Alright, so there are a couple of extra points for you to take note. Okay, you have to take note of the charges. So just now in the example of ammonia and the Rx, there was a positive charge that was generated. We compared the charges to make sure that it was charge neutral, because there's a conservation of charges. And then finally, you have to liberate the neutral product if applicable, only if applicable. Okay, so this is the idea behind nucleophilic substitution mechanism.